This is the screencast for section 2.5, example 4, factoring a polynomial with complex zeros. So in examples 1, 2, and 3, we were given the zeros and we had to come up with the function. Now we're given the function, we have to come up with the zeros. And that means factoring. Well, back in section 2.2, we learned how to factor using synthetic division. So that's what we're going to use. We need to start off though with the calculator to give us an idea of where to go with our factors. I took it upon myself to graph, find a good window, and look ahead of and see where the zeros are. It looks like I have zeros at -2, +1, and +3. So I'm going to start with -2 and put that into synthetic division. -2 worked. It is a 0. So I have started out with the function x to the 5th minus 3x to the 4th minus 5x cubed plus 5x squared minus 6x plus 8. And now, after putting -2 through synthetic division, I have broken up that polynomial function into, see, if -2 is in fact a 0, because it has remainder 0, that would be x minus -2, or x plus 2 is the factor. Then what's left over is, constant, x to the 1st, 2nd, 3rd, 4th. So we have x to the 4th minus 5x cubed plus 5x squared minus 5x plus 4. Now I need to continue to break down that piece. So I'm going to use another one of my possible zeros, and I think that's going to be +1. So I'm going to put 1 in through synthetic division, but only using the first. I don't need to work with the remainder, and I'm going to continue from where I left off. So I'm going to use the coefficients 1, -5, 5, -5, and 4 to continue to break down into smaller and smaller pieces the original function. So I can see that 1 is in fact a 0 because it had remainder 0. So now I have the piece x plus 2 that I got from the first synthetic division. And then I broke up this part of the polynomial into x minus 1. So since 1 is a 0, x minus 1, x minus k, is the factor. And then what was left over was, so that's the remainder, constant, x squared, x cubed. X cubed minus 4x squared plus x minus 4. I have one more 0 to try. I think 4 is a 0. I know I said 3 earlier, but I miscounted. You probably noticed that. 1, 2, 3. Yes, Miss Larson. 4. So 4 is a 0. I'm going to put that through synthetic division. And now since 4 is a 0, I have the x plus 2 from my original synthetic division. Then I have the x minus 1, because I found out that 1 is a 0 in my second level of synthetic division. This last level of synthetic division broke this cubic piece into x minus 4, x minus the number I found that was a 0, and left over is, this is the remainder, so that'll be 1 x term x squared, so x squared plus 1. So I've identified 3 of the zeros, but there are 2 more zeros in this piece. So I just need to set that equal to 0 to find out what those zeros are. And if you remember, the square root of -1 is I. So I have plus or minus I as my other 2 zeros, which I now have my complete factorization. F of x equals x plus 2 times x minus 1 times x minus 4. And now since positive I is a 0, x minus I is a factor. And then since negative I is a 0, x plus I, or x minus negative I, is a 0. There are my 5 zeros. So to answer my question, see, it says find all the zeros and write f of x in its linear factorization. Well, this is the linear factorization. As I explained in screencast 1, each one of these individual factors, if you graphed them, would be a line. So this is a linear factorization. It includes some imaginaries, which we don't usually work with, but in this case the directions said linear factorization, so I'm going to have some imaginaries in there. It also said find all of the zeros. So I'm going to list my zeros. They are x equals -2, 1, 4, positive I, and negative I. There are 5 zeros, degree 5 polynomial. The now try problem for example 4 is number 29. Find all of the zeros and write the linear factorization of the function. So again, I had to graph the problem, find a good window to see where I can even start with my zeros. So the zeros, it looks like -1 and 1 might be zeros. Now, of course, your calculator can actually find those zeros for you. I get that. But I'm going to need to see the progression because you need to factor using synthetic division with -1 and 1 in order to find the other two zeros. So let's first start with putting -1 and then +1 in synthetic division. So I started out with the polynomial x to the fourth plus x cubed plus 5x squared minus x minus 6. I did synthetic division. So essentially I divided by x plus 1, x minus the number I used, the k value. So x minus -1 is x plus 1. Then I got my remainder, or excuse me, my quotient is, let's see, constant x squared, x cubed. So 1x cubed, no x squared terms, 5x minus 6. So I'm beginning my factorization process. I still need to work with another one of the zeros. Let's try then 1. I'm not going to work with the remainder. I'm just going to use the first four numbers, leaving 0 as a placeholder. So since 1 is also confirmed to be a 0, I have factored x cubed plus 5x minus 6 using its leading coefficients in synthetic division into x minus 1 because +1 worked in synthetic division. And then the rest of it would be x squared plus x plus 6. Now I don't know what the other two zeros are. I can tell you that they are imaginary because this graph doesn't cross the x-axis anywhere else. It might be that they're irrational, but they are imaginary. In this case, and I know that because they don't cross the x-axis. Irrationals would cross the x-axis. So now I have a quadratic expression, and I can use the quadratic formula to find out what the rest of those zeros are. So now I've found the factorization. Y equals x plus 1 from my first round of synthetic division times x minus 1 from the second round of synthetic division. Now, -1/2 plus the square root of 23 over 2i is a 0. What? So x minus that mess, -1/2 plus the square root of 23 over 2i, is a factor. And then x minus, remember it's always x minus the 0. So x minus, this would be -1/2 now minus the square root of 23 over 2i. Now if you remember from some previous problems, we don't like fractions sitting in our zeros or our factored terms here. So what I'm going to do is factor out a 1/2. Are you ready for this? It's going to be y equals, so this is going to stay the same, x plus 1 times x minus 1. Now to divide by 1/2 is the same thing because I'm factoring out a 1/2, which is dividing by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. So x becomes 2x, 1/2 times 2 is 1, and then again I'm dividing by 1/2, so multiplying by 2, the 2's would cancel out, so this is just square root 23i. I'm going to do the same thing in this second trinomial here. I'm going to factor out or divide by 1/2, which is the same thing as multiplying by 2. So if I factor out the 1/2, I get, let's see, 2x plus 1 plus, and now since I factor out the 1/2, just square root 23i. So to simplify that, I get 1/4 times x plus 1 times x minus 1 times 2x plus 1 minus the square root of 23i. I am so running out of room. That's right, I know you wish you could do that. Okay, and then last term, factor 2x plus 1 plus square root 23i. Now I've got my 1/4 out in front so that all the rest of my my factors do not have fractions in them. And let's see, find all the zeros. So I need to identify what the zeros actually are. Zeros are +1, -1, oh my goodness, -1/2 plus or minus the square root of 23 over 2i. So that's two of them, -1/2 plus the square root of 23 over 2i, and -1/2 minus the square root of 23 over 2i.